Potentiometer tapers. You could get a standard linear taper like the blue one, an audio taper like the red one, or even a reverse audio taper like the green one. But what if you need something weird like this purple one? Well, I'm Professor Fiore, and I'm going to show you how to make your own custom tapers right now. All right, so you want to learn how to make a custom potentiometer taper. You want to be able to create your own resistance variation curve. Well, you've come to the right place. Let's start with a simple linear pot. All right, the position that you have on the wiper arm tells you what the output voltage is, just the voltage divider. And it's linear, so we find that the percent of change in that position is simply a function of the rotation, right? In other words, you move it 10 degrees, you get a certain amount of resistance change. That's the end of it. So as it's drawn here, this is sitting at 50%, meaning this 10K pot gets split into two pieces, 5K up here, 5K down here. So if we do a voltage divider on that, we should get half the voltage. In other words, 10 volts in this case. Gets divided in half, and we get 5 volts. No biggie. I come over here and I say, well, let's change it to 25%. And again, conveniently, because we're using 10 volt source, we should wind up with 2.5 volts. And sure enough, we end up with 2.5 volts. Basic linear pot, no big deal. All right. So I go out and I get a linear pot, right? Linear taper pot, which would be this blue line. And that's what we see. In another video, we looked at audio taper pots. That would be the red line. And that's primarily used for something like a volume control. It's also possible to buy what are called reverse audio taper pots or anti-log pots, which would be the green line. You know, and this red curve, because they're relatively common, right? You use these for volume controls. This red curve basically helps compensate for the way in which we humans hear stuff, right? In this sort of super logarithmic fashion. But, you know, you might have a need. You might have a need to create something weird like this purple line that I have in here. So what do we do? Well, you know, if you had unlimited funds, you could just go to a manufacturer of potentiometers and tell them to make you one. Right? But it's going to cost a lot of money. So if you're, you know, futzing around with stuff in your home lab, that's not practical. So what can we do? Well, it turns out there's a very simple thing that we can do to create a curve like the purple curve, or like a cross between the purple curve and the green curve, or the purple curve and the red curve. You know, we could make something that's like partway between linear and the log, or maybe it's mostly log, but a little bit of a linear thing for part of it, or maybe a little bit of the anti-log reverse audio taper on another part of it. You know, just imagine grabbing this purple line or the red line or the green line and sort of twisting it around. Now, it turns out you can't do everything, right? I mean, there are some impossible curves. There's no way you're going to get a curve that's going to go like this, you know, up, down, up, down, up, down. But, you know, these simple kinds of shapes we'll be able to generate with just a couple of resistors added to the potentiometer. Now, you might have to add a high Z buffer after this. All depends on what your load is. If you have a low impedance load, that can screw things up. Okay? So, let me show you what we're looking at here. I'm just going to take my normal potentiometer and I'm going to stick a couple of resistors, an upper resistor and a lower resistor that go from the tap to the outsides. Right? That's it. And what I'm saying is, by playing with these resistor values in relation to the size of the pot, you can create weird curves. So I'm just going to prove this point very straightforward. I've got the pot set for 50%. Now, you would expect this thing to actually produce 50%. In other words, 5 volts again. I mean, I'll have 5K in parallel with the 10K up here, and I'll have 5K in parallel with the 10K down there. It's the same resistance, so I should still wind up with 5 volts. And you're saying, hey, Prof, where are you going with this? There's our 5 volts. Well, okay, that's the dead nut center, and we know the extremes are still going to work, right? I know that if the wiper arm goes way up here, okay, then this shorts out our upper, so who cares? And the fact that I have a different lower resistance, I'll have 10K in parallel with 10K for 5K, it doesn't really make any difference because there's still 0 up here. And the same thing will be true when we bring the wiper arm all the way down to here, right? So those 3 points, the 2 outside extremes in the middle, are the same. But what happens if I do something else? Like I go, oh, let's go 25%. Now, when we did this with the straight linear, we got 25% of the input. In other words, 25% of 10 volts was 2.5 volts. What do we get now? I get 3.18 volts. Why? Well, because these resistors load the pot and they change the voltage divider ratio. So when I bring this thing down to 1/4, what happens is this is 2.5K, and that 2.5K is in parallel with 10K. So that gives us a value a little bit less than 2.5K, maybe 2K, somewhere around there. But on the upper end, a similar thing happens, right? The 10K winds up being in parallel with the residual of the pot, which in this case is 7.5K. That produces a bigger change than what you saw down here. It's not like these resistors up here are going to be the same value as what you had down here when the wiper arm was in the center. That unbalances the divider. So now we actually see that we get a little bit more voltage out of here when the wiper arm is at 50%. Now, if I start monkeying with these values, make some big, make some small, we can get a lot of variation here. We can get crazy variations. And the end result is, like I said, we can get something that approaches, like a log pot, an audio pot or an inverse audio or some other weird compound kind of thing like the purple curve over here, right? As a matter of fact, this is kind of what we're getting right now. When we put 2 equal valued resistors in there, we're going to get something like this purple curve. If the resistors are not very big, the change is not going to vary much from the linear curve. In other words, there'll be a little bit of a rise here and a little bit of a dip here, but it won't be huge. The smaller I make those resistors compared to the size of the pot, the more exaggerated this shape, all right? But I don't have to leave these resistors the same size. I can have one of them big and one of them small. As a matter of fact, I can get rid of one of them and just have the other one. Now, this is going to take a little bit of calculation if you want to get a good idea, a good overall visual on what your pot's actually doing. Now, you might say, why would I ever want to do this? Well, I can imagine a situation where you would normally use a linear pot, but you want to be able to tweak values maybe around the center a little bit more. For example, if you had, like some kind of equalizer, cut boost. So right here would be the middle, no cut, no boost. Then you could imagine sweeping on the other side to the cut and boost sides. And if you had a curve like this purple one, what would end up happening is you would have much finer control around the center. And you'd have much larger jumps toward the extremes. So in other words, if you think of a round pot, right, around 5, you move it a few degrees, you're getting, like a dB or 2 change. But when you're way off on the ends, down around like, 1, 2, or, 8, 9, 10, then that same amount of rotation, instead of giving you a dB of change, might give you 3 or 4 dB of change. Because maybe you want to get the tweakiness right here. And if you're going to do wholesale changes, well, okay, just crank the knobs, right? That's a possibility. Make your own custom kind of thing. But in any case, trying to calculate that out can be a little bit of a pain, right? So this is why we have other tools. So what I've done is I wrote a very short little Python script in a tool called SciDAVis, SciDAVis, and it stands for Scientific Data Analysis and Visualization Software. It's freeware, right? It's basically an OER, an open educational resource. So just search for that. You can download this and use this to your heart's content. So I'm just going to open that up right on top of here. All right, so here's my SciDAVis plot. All right, this is the program. This is an output graph that I'm getting. And so I basically wrote two functions. One just gives me the linear, which is the black line. This is what you would expect on a linear pot. So you notice 40% rotation, and we get 40% of output. 80% rotation, I get 80% of output. The red is my custom function. So I'm going to edit the function just to show you what it looks like. Pretty simple, right? I set a value for the pot, a value for the upper parallel resistor and the lower parallel resistor. And then I just use a variable x to represent what the percentage is, the percent of rotation. And then I just do some very basic computations based on x first to get the two pieces of the pot, the upper and the lower piece, right? Rpotlow, Rpot-Up, right? The upper and the lower piece. Then all I have to do is a little, parallel combo to get the upper pair and another parallel combo to get the lower pair, just using product sum rule over here. Then take those two results, which would be R low and R up, apply the voltage divider rule, you've got the value. And then we just iterate that. So essentially, I'm just saying start x at 0, go x to 100, that's percentage, and just do 100 points, meaning every percentage point, and plot it. Okay? And this is the curve that we get. So I'm using, in this case, a 10K pot and a pair of 1k ohm resistors. All right? What I had originally on here was all 10Ks. So this is using 1Ks for the two outside resistors, and you can see what's happening over here. All right? Just to show you what's happening, if I turn them all into 10Ks, so I could just come in here and just change these and then apply that function, and you can see, all right, it's doing the same thing, it's just not as extreme. Right? If I only change, one of them, like I just changed this one, so now I've got 10K pot, 10K upper resistor, and a 1K lower resistor, right? Now I'm getting something that kind of looks like a log taper. And, I can just use the one resistor. So I'll do that just by setting our upper to like a crazy huge value, right? 10 to the 30th. And you can see how that's working. Or I could just flip that around. All right, let me go down here and make this like the huge value. So now I only have the upper resistor, right? And I'm getting something like a reverse audio taper pot. So, as you monkey with these values, you can get some, interesting kind of shapes over here. All right. That swings out. We could be a little less maybe aggressive with this. All right, do something like that. Oops, try that. All right, bring that around. All depending on what you want to do. So you could sit here and just kind of play with this and get interesting kinds of curves, right? Now, as I said, you can't get anything too crazy, at least with this. You're not going to get something that goes up and then down and then up and then down. It's just this simple kind of, raise one end, lower the other end kind of thing, or, bring the whole thing up, bring the whole thing down. So you could make, using this technique, as I said, essentially an audio taper pot, right? Just using one resistor. And if I come down here and I just say, let me make this like something like that, and I'll make this a huge value, which will just make it look like it's infinite. So now I'm just using a lower resistor, practically speaking. We get something like this, right? And you can monkey with that. So 50% rotation. I would like maybe a 10%. So maybe I want this curve to be a little lower. So maybe I'll do something like this, right? And I can push that around and do things. All right, so there's 50% rotation. That's about 10%. So if I don't have an audio taper pot kicking around, I can do something like this. All right, cool. Now, the thing you got to be aware of is your load. If you have a load out here that's around the same size, that's let's just say not significantly larger than these things, that's going to further alter the impedance of your voltage divider. So if that is the case, you would like to have a high impedance buffer out here. So that way you can dial up exactly what you want for your resistance values, get the taper you want, and it's not going to make a difference what you're driving. All right. But that's kind of cool. So now you can take a linear taper pot, add just 2 resistors, maybe just 1, depending on the shape you want, but no more than 2 resistors. And you can make some really kind of, cool results out of this thing. Bend that resistance curve to your will. Ooh, that just sounds so evil. Okay, hope you enjoyed this one. This is Professor Fiore saying, take care and I'll see you next time.